Hey guys, today we are expanding on yesterday's lesson over simplifying with variables. So in this case, we're going to assume all of our variables are positive. We're not going to deal with imaginary variables under the radical. So simplifying with variables means when we are simplifying something with a variable or with a number, we need, in the case of a cube root, we need 3 of them to be able to take something out. So we would need to be able to pull out 3 x's to end up with 1 x outside of that radical in example A. The other way to look at it is that if we change that over to a fraction, then we have 9 over 3. And 9 divided by 3, we have 3 sets of 3 there. So the cube root of 27 is 3. And then just like I was saying here, we could rewrite that as 9 over 3. So we get x to the third. And that's simplified completely. All right, then we're taking to the 1/2 power here. So 16 to the 1/2 is the same thing as the square root of 16. So that's a 4. And then g to the 4th to the 1/2 power. 4 divided by 2 is 2, so g squared. And then h to the 2nd to the 1/2 power is h to the 1st. We have the 5th root of x to the 5th over y to the 10th. So the 5th root of x to the 5th is just x. The 5th root of y to the 10th is just y to the 2nd. 10 divided by 5 is 2. All right, in this case, we need to, on part D, we need to divide, so we're subtracting exponents. So 18 divided by 6, we still treat like normal numbers. That's a 3. Then I have r to the 1st and r to the 1/4. So 1 minus 1/4, or 4/4 minus 1/4 is r to the 3/4. And then I have s to the 2/3 with nothing else. And I have t to the -3 on the bottom. Well, since it's a negative on the bottom, we're going to bump it up to the top to be t to the +3. And that's your answer for that one. All right, let's try some more of these. So I have the 4th root of 12, d to the 4th, e to the 9th, f to the 14th. So anytime I might have things left over, I'm going to set up in front of the radical numbers and then inside. So can I take anything out of the 4th root, or of 12 with the 4th root? And I can't. There's not anything to the 4th power. D to the 4th, all 4 of those would go to make 1 outside. E to the 9th, well, I can take 8 of them out. That gives me e squared outside, because 8 divided by 4 is 2. And then I still have 1 left over inside that can't come out. And then f to the 14th, well, 14 divided by 4, 12 divided by 4 would give me 3. And then I still have 2 left over inside. And that's kind of how I look at it, to keep that inside-outside as simplified as possible. The cube root of 24. Is there a perfect cube I can take out of 24? Well, I know that the cube root, or I know that 24 can break up into 8 and 3. So that means I'm going to be able to take the cube root of 8 outside, which is 2, and then I'm left with 3 still inside. And then x to the 7th, well, x to the 6th, 6 divided by 3 would give me x squared, and then I have 1x left over. Y to the 13th, y to the 12th, 12 divided by 3 would give me 4, and then I still have 1y left over. z to the 26th, well, z to the 24th would be z to the 8th, and then I have 2 z's left over inside there. So that's my final answer for that one. All right, then I have the 5th root of g squared over h to the 7th. So I'm going to split that out just like we did before. And so this is g to the 2/5, or the 5th root of g squared. And this is h to the 7/5. Well, again, to get rid of that in the denominator, we want to make that a whole number. So I need 3/5 more to get that to be h squared. So I need 3/5 here, and I need 3/5 here then. So then I have the 5th root of g squared, h to the 3rd, over, then I have h to the 10/5. Well, 10 divided by 5 is 2h squared. And so that really is our final answer. That's as simplified as we can get it without putting a radical in the denominator. All right. Then we can simplify with adding and subtracting here. So we want to see if we can take anything out to make those the same, the radicands the same. So 6x to the 5th. Well, I think the 6 is stuck, but that x to the 5th, I know that I can take 4 of those x's and pull those out front. So that would give me 2x out front. And then I have the 4th root of 6x, which looks so much more like the 4th root of 6x over here. So then I have 2x plus 1x, which is 3x, the 4th root of 6x. And that's my answer for this. In this case, 4x to the 5th, we're taking the square root. Well, the square root of 4 is 2. X to the 5th, I can take out pairs of x's since it's the square root. So I can take out 2 pairs, and then I have 1 square root of x left over. Then I can take out 1 pair, and I have 1 left over. So I have 2x minus 1x, which is just x. No, sorry. I have 2x squared minus 1x. So I have 2x squared minus x, radical x, if I pull those out front. So that would be your final answer. All right, guys, a little bit shorter today than yesterday's lesson. If you have questions, feel free to come in and see me. If not, I'll see you in class.